Hello everyone, this is our lecture on probability. Before starting a lecture, I am replying to your comments. These are two codes to remember in which order you have to perform the arithmetic operations. Don't confuse yourself. Whatever the code you are using, the underlying conceptual skeleton should be maintained. First, solve what is inside the grouping symbols like brackets or parentheses. Then jump to exponential expressions. Division and multiplication rank equally. So that's why in PEMDAS the alphabets are swapped and it doesn't matter. They have an equal rank. Solve division and multiplication from left to right, whichever appears first. And in the same way, you have to consider addition and subtraction at the same time, but solving from left to right, whichever comes first. So there are 4 steps, not 6. Probability. What is the chance and likelihood that something will happen? Probability provides the answer to this question. It measures the chance or likelihood of an event happening. Its value range from 0 to 1. It is usually expressed in decimal or as a fraction. Probability of 1 means that something will definitely happen. Guys, if you haven't taken the previous lecture, do not proceed. Please go back to the last lecture because I have already given a little intro of probability in the previous lecture and we are going to resume it from where we have left. We have arrived at this formula. Probability is favorable outcomes divided by the total number of possible outcomes. There are some terms related to probability, and as we will solve the problems, we will figure out the features of probability and understand the related terminologies. What is the probability of getting king on a standard deck of 52 cards? How many kings we have? So our total favorable outcomes are 4 and divided by the total number of cards 52.07. What is the probability of getting an even number when a dice is thrown? There are 6 possible outcomes and the total number of favorable outcomes are 3. 3 over 6, 0.5. 0.5 means like 50% and you can see that even numbers are half the number of total outcomes. What is the probability that Eid would be on Sunday? We are interested in days of the week. How many days are there in a week? 7. And our favorable outcome is Sunday, so 1 over 7, 0.14. If you purchase a lottery ticket and there are 1000 tickets, what is the probability of your winning? So you have just one ticket out of 1000 tickets, 1 over 1000, 0.001. Now I am going to modify this question. If you purchased a 3-digit lottery ticket, each digit range from 0 to 9, what is the probability of your winning? This is the same question. In the previous question, total possible outcomes was given 1000. But in this question, you have to figure out the total possible outcomes from the given information. For every digit, there are 10 possible options to choose from, 0 to 9. So 10 into 10 into 10, you have to count the total number of possible outcomes in this way and then solve the problem. Counting the number of outcomes is actually embedded in probability concept. When we have a large number of possible outcomes, then we use some formulas. Our next lecture will be based on those formulas. If you roll a dice, what is the probability of getting 2? That 2 will face up. 1 over 6 is the answer because each side has a probability of 1 over 6. Let's see one interesting feature of probability. There are 6 possible outcomes and if we add the probability of all the outcomes, we get 1. So we can say that if the experiment consists of all the available possible outcomes, then the probabilities of all the outcomes add up to 1. This feature of probability has some implications. Let's see. If a dice is rolled, what is the probability of not getting 2? I am taking very primitive example just to make visible other features of probability. Because you know that all the probabilities add up to 1 and we want to exclude the probability of getting 2, 1 minus 1 over 6. This is called a complement rule. When you will solve advanced questions, you will come to know that this rule is very effective. Sometimes it is convenient to subtract the probability that is not required from the total probability of 1. Probability of mutually exclusive events. A manufacturing firm classified their products into quality A, B and C. Last production of 1200 products classified as follows. If we randomly choose a product, What is the probability that a particular product will be either in quality B or C? Do you remember this terminology from the previous lecture? Either in quality B or C. From the Venn diagram, you can see the events are mutually exclusive. They don't overlap. And all the probabilities add up to 1. So when the events are mutually exclusive, probability of B or C is equal to probability of B plus probability of C. Probability of one or the other event occurring is actually the sum of their probabilities. Examiner can ask in this way too. What is the probability of not getting A? Using complement rule, 1 minus probability of A. Our last lecture was based on overlapping events. We started our intro of probability with this slide. This is the example of joint probability. In joint probability, the events are happening together. Taking this question again, if a teacher randomly selects the student, what is the probability of selecting a student participating in either debates or sports? So the events are not mutually exclusive. A Venn diagram is showing this. We are familiar with this formula and how it was operationalized in the last lecture to remove the replicated event. In the same way, we have to subtract the replicated probability. What is the probability that a student selected is neither participating in debates nor sports? Now we are interested in the probability of this area. We have already subtracted the replicated probability, so we can easily use the complement rule. You know the probability of this whole region. Just use the complement rule and subtract the probability of this region from 1. You can also check it. When you were solving the counting problems, you calculated that 8 students were not participating in any activities. So 8 over 20 is 0.4. You can see that the sum of the probabilities is not equal to 1. So we have to subtract the overlapping probability, and you have to subtract the overlapping probability at this stage. Concepts are easy and based on the pattern you have already studied. In some questions, we calculate the probabilities based on past information about an event. This is a different kind of probability. There is a question. In an engineering firm, among 50 projects, 2 were failed. What is the probability that future project will be successful? Successful projects are 48. Because we are interested in successful projects, so probability of success is 48 over 50, 0.96. When 2 coins are tossed, what is the probability of getting 2 heads? Let me tell you about the independent events. 2 events are independent if the first event does not affect the probability of the second event. Like getting heads in a first toss doesn't affect what will appear in a second toss. When the events are independent, the probability of both the events happening together is found by multiplying the 2 probabilities. This is the special rule of multiplication. In a first toss, probability of getting heads is 1 over 2, and we multiply it with the probability of getting heads in a second toss, 1 over 4. We are multiplying it so that it has the total number of our outcomes in the denominator, and our favorable outcomes is just 1 out of that 4 options. When 3 coins are tossed, what is the probability of getting 3 tails? We have 2 options for the first toss, 2 options for second toss, and 2 options for the third toss. So in this way, 2 raised to power 3, we have 8 total number of possible outcomes. And we'll solve it in the way we have done before. If 3 coins are tossed, what is the probability of not getting exactly 3 heads? Probability of getting exactly 3 heads is 1 over 8. And using the complement rule, 1 minus 1 over 8. When 3 coins are tossed, what is the probability of getting at least 1 head? Sometimes examiners just play with the words. How this question is different from the previous one? Questions may appear difficult by tricking your brain to focus on something and ignore the easy solution. At least one head means that two heads are also allowed. So we are interested in all the options except getting the three tails. So using the complement rule and subtracting the probability of getting three tails. A bag contains 4 pink rubbers and 10 blue rubbers. What is the probability of picking pink rubber on a first attempt? Then again picking pink rubber on a second attempt, with replacement and without replacement. Let's differentiate between independent and dependent events with this example. In with replacement scenario, when we pick the first rubber, we actually put it back, and the number of outcomes remain the same for the second rubber. And the probability of picking the first rubber doesn't affect the probability of picking the second rubber. So with replacement scenario involves the independent events. In the second scenario, when you are not going to put the rubber back, the probability of picking the second rubber is changed because the outcomes are reduced. After picking the first pink rubber, the probability of picking the second pink rubber is 3 out of 13. Because 3 pink rubbers are left and the total number of outcome is also reduced to 13. So dependent events also involves the conditional probability. This reduced fraction is called a conditional probability. A bag has 3 black marbles, 4 white marbles and 5 green marbles. What is the probability of picking black marble on a first attempt and then white on a second and then white again in a third attempt, with replacement and without replacement? When the events are independent, the probability of picking a black marble is 3 over 12. And because you are going to return that marble in the bag, so the probability of picking the white marble in a second attempt is 4 over 12. And in a third time, this probability doesn't change because we have to return the marble in the bag again. In without replacement scenario, the probability of a second attempt is changed because the denominator is reduced to 11, as we are not returning the black marble. And in the third attempt, the numerator is also reduced because we are not going to return our white marble, and there are 3 marbles left. A bag contains 4 gold coins and 8 silver coins. What is the probability of picking 4 gold coins on 4 attempts without replacement? So the events are dependent. On taking the first gold coin, we are left with 3 gold coins, and the outcome is also reduced by 1. And then we are left with 2 gold coins out of 10, and then 1 gold coin among 9 coins. We have seen that dependent events involves the conditional probability. Now let's see the conditional probability individually. Taking this question again and modifying our requirement, what is the probability that a student selected has participated in sports given that he has participated in debates? In simple terms, among the debate students, how many students have participated in sports, and calculating the ratio of it, like what proportion of debate students have participated in sports too. This is a conditional probability. Conditional probability has reduced our sample space. Our formula for conditional probability is probability of sports given debates is equal to probability of debates and sports divided by the probability of debates. 0.25 over 0.35, 0.71, or 5 over 7, 0.71. Let's solve a problem based on a contingency table. Given that all the A plus candidates, what is the probability of selecting female? This is a conditional probability. Total A plus candidates are 115. Keeping our focus on A plus candidates, we have to see that what amount of females are there. So probability of females given A plus candidates is 60 over 115, 0.52. What is the probability of selecting a candidate who is a female and who got A plus in exam? Just a little variation of words, but here you have to calculate a joint probability that also involves a conditional probability. Probability concepts are not confusing if you pay attention to little variations. You can best understand it with the help of tree diagram. We started with the total amount of students, 341, and they are divided into two categories, male and female, 211 and 130. On the first stage, we are interested in the probability of females among the total students. And then among those females, we are interested in that how many have got A+. You should be sensitive to words like and, or. You have seen different shades of joint probability. When the events are not mutually exclusive, when the events are independent, and when the events are dependent, in which we have seen the role of conditional probability. So we have learned these terminologies related to probability. You must know what's the difference between outcome and event. For example, in a die tossing experiment, we have 6 possible outcomes. And there are many events, for example, getting an even number, getting an odd number, having number greater than 2. So event is a collection of outcome. We group outcomes to form an event. We used special rule of addition when the events were mutually exclusive and general rule of addition when the events were overlapping. And we used special rule of multiplication when the events were independent and general rule of multiplication when the events were dependent. So this is your assignment. Deck of 52 cards. Our context is same, but the questions are based on all the concepts we have studied earlier. Identify where the events are overlapping or where they are mutually exclusive or independent. If the question is about conditional probability or it involves conditional probability. You can comment your answers below.